So when you have a structure like this, it's possible to apply these springs. So we can analyze the structure. So let's see what we can gather. Right. So when you perform the 3D modeling, one of the important parameters that you can obtain is the natural period of vibration of the structure. So if you go deform shape, model, so you'll be able to see the way that the structure behaves. And with that, you will be able to see the natural period of vibration of the structure. And sometimes when you want the natural period of vibration of the structure, you might actually apply a set of supports at the ground level and determine that. The reason is in the actual structure, we have soil here that we have not modeled fully. So because of that reason, if you want, you can actually apply supports at this level and decide the natural period of vibration, which would be more representative. And when we did the wind analysis, we use these values of natural period of vibration. So the values that you determine here, by assigning the correct mass, you will be able to use it. And also, another load that we did not apply in this particular case is the weight of the facade. Weight of the facade. So weight of the facade will act on the periphery. So here you can see the weight of the facade will act on the outer periphery, and so you will be able to see the effect of that on the bending moments and shear forces of outer members. But in this particular case, I have not applied that particular load. So you have to apply that. And then from the results of this, you'll be able to see that if we view one of the planes, and if you ask it to display deformed shape, and when you want the deformed shape, you might have to give a load case or a combination. And you can also determine what is the kind of deformation that occurred due to wind, which is about 59 millimeters at the top of the structure. So here you can see the deformation is about 59 millimeters at the top of the structure. You can see U1 is 0.0596, so it's 59 millimeters at the top of the structure. Then similarly, you'll be able to see the forces and stresses. So here we have defined a load case called envelope XY, and that is, if you look at the load combinations, you can have so many different combinations. And I explain you what is combination 1, and that is all the loads with 1.0 GK and 1.5 WK. And then you can get combination 2 with all the loads are there with 1.35, but live load is also there. And here you can see the live load should be 1.05. That is 1.5 into 0.7. So it is 1.05 divided by 2. So this should be 525. And here you can see I have allowed for 50% live load reduction. And then you get wind load X as well, which is considered as the primary action. So similarly, in load case 3, dead and live loads are primary action, and wind load has become the secondary action, and that's why you get 1.5 into 0.5, it is 0.75. And then combination 4 is also there, and it carries all the loading with live load reduction. And then you have the envelope in X direction. So all these combinations in X direction. And this is all the combinations in Y direction. And here you can see I have used the term envelope. So it will not be added up as in the earlier case. What you get is the maximum value. And then envelope XY. And similarly, the service load combinations also have been sorted out. And there's a service envelope in XY direction as well. So it considers all the loads acting in X direction and all the loads acting in Y direction. Then, so when you do an analysis like this, here you can see the kind of bending moment that will be induced in the frame. If you are interested, you can find the axial loads as well. And for the shear walls, so you get all the loads on the frames, but to get the loads on the shear walls, then you can ask the program to display shells, and you can find the stresses acting in the, or the forces acting in the vertical direction in kilonewtons per meter. And here you can see the value sign 1800 something. And here you can see you get some low values at the bottom. Can somebody tell me the reason? Here you get high values, here you get low values. Can somebody tell the reason? The reason is, I'm looking at the wrong stress, because I should be looking at the minimum value, not the maximum value. So when you are dealing with shell elements, now you can see the actual force is 5,400. And here you get a concentration of load. So when you have the concentration of load, and if the there can be many reasons for this concentration of load. And one reason is, if you are having a support here and here and no support in the middle, then there can be certain concentration of loads here. So basically, when you know these loads, you can actually design the shear wall to resist these axial loads. Then we can also get some idea about the loads on piles. So if I go for 2du, and there are some piles on this particular line. So here you can see the piles in that particular so we can find the axial loads acting on the piles, and here you can see the loads on piles are in the range of 4,348, the ultimate loads. But when it comes to pile design, we ought to need other service values. So you can also find the service envelope. So the loads on piles are in the range of 4,297. And when you look at the service loads, these are the values that we use for the design of piles, and the values are in the range of 3,106. So in addition to that, you can also see what are the values of moment acting on the piles. So you can see they are also not excessive. And on this one, here you can see the kind of moments that will act. And here you can see it comes this way and then goes this way. But what actually happens is going that way, and the reverse diagram is going this way. So I think if we look at one, if you look at Winx, now you can see the type of moments that will be acting on the piles. So what actually happens is now I'm applying the load only in one direction. But when you look at the envelope, we apply the load in both directions, x direction and minus x direction. So because of that reason, you could not see the fact that some negative movements will act. And the pile will behave as if it's fully fixed at this level. Pile will behave as fully fixed at this particular level because the bending moment on the pile is maximum and pile is embedded in soil. And because of that reason, the maximum stress on the the pile will act as if it is fixed at this particular point, and the maximum stress on the pile will act here. But here also you can get some bending moment, and here also you can get some bending moment, and the bending moments on those two locations should be checked to see whether they are excessive. But most of the instances you will find that because we are having 4 piles, these moments cannot be excessive. So if you're having, say, single piles supporting a column, then the bending moments can be higher than this. But because we are having 4 piles supporting the column, the bending moments will be lesser. The reason is these piles can actually resist the bending moment acting on the column by utilizing the axial force carrying capacity of each of these members. So that's why, the bending moment on the piles will not be that critical. So basically, when you do the complete modeling like this, you can get many useful information. And then a topic that we did not discuss is what happens when you have a transfer plate. So what actually happens is when you look at the building regulations that are used in Sri Lanka, they actually request you to provide adequate car parking. So the only way that people can provide adequate car parking is by utilizing the lower floors. Otherwise, you have to have a very large garden for providing the car parks, open car parks, which is not practically possible. So because of that reason, you have to go for the first few floors would be a car park. So in the case of car parks, we have to allow for vehicular movement. And one of the requirements is road. If you're having road, the traffic moving in 2 directions, then you will find you need to have a passage that can allow the vehicle movement. And the width of the passage has to be about minimum of 7.3 meters. So when you have a passage of 7.3 meters, then you will find the same kind of column pattern that we have used here cannot be used in the lower floors because it will be in conflict with the movement of the vehicles and also especially the requirements of urban development authority. So because of that reason, what we do is we have to go for a transfer plate, and transfer plate is an element with a big thickness like 2 meters, and the idea of transfer plate is to resist the loads from above and transfer those to columns located below. Transfer those to the columns located below. So we'll have a brief look at how to create a transfer plate. Will not take much time. I'll show you only the important points. And then, so basically I'm not going to complete the model. I'm going to show you only the very basic information. So before we do that, do you have any questions to ask from this particular exercise that we have done before lunch and also now. And any question that you would like to ask? Okay, so then we'll move to the transfer plate, and I'll save this as file. So I will select flow at this level, and let's say the grid below, instead of this particular column continuing, we like to have a column 1.5 meters this way, and we like to have a column 1.5 meters this way, x and y, and also we like to shift this line of columns by another 1.5 meters. So basically, if that is the case, and we like to continue by having columns below the transfer plate somewhere here along this line, and above the transfer plate at these locations. So we have to see how we deal with a situation like this. And what we can do is, we can ensure that the transfer plate is properly defined, and also the columns above the transfer plate will come and meet at the transfer plate, and there is also a connection, proper connection between the columns below and the transfer plate. So we have to make sure there's proper connection above the transfer plate and below the transfer plate. That can assure that the transfer plate is capable of transferring loads which are acting in the middle of the transfer plate to the supports which are located away. So I will very quickly show you a few important things. So we'll see that we can just replicate it. I'm not going to complete this. I'm just going to start and demonstrate few things. Minus 1.5 and 1.5. You can extend it, and so this is 30. Replicate at 33. And also can extend. Okay, to offset. And then let's define the transplate as a section having a thickness of 2000, having a thickness of 2000 millimeters, and we'll use same concrete as beam concrete, but if you want you can change it later. And then we can actually now indicate the transfer plate. So here we'll replicate this at 1.5 20 times. This one will 6 divided by 1.5 is 4. So we replicate this also the same, and we replicate that. (16 times). So now you can see the new transplate. So to make sure that you know all these members are of the correct thickness, we'll assign the transfer plate to those members, and then I will also divide areas into 7.5 divided by 4 is divided by 1.5 is 5. 5 is to 4. And here you can see now everything is divided. So I'll save this. Then I'll say save as. So now you can see that we have extended the transfer plate. So here the plate has been extended, but no columns there. And so what we can do is we can define a column which is larger than column going to have even a bigger column below. Muscle I saw it. I'll see. I'm doing a lecture now. I'll after the lecture. Okay. So we know that we are going to get new columns at these locations. And we can extrude and create the columns. And what I can do is view, view 3D. So I can look at this particular view, and I can also look at this particular view in the two windows. And here what happens is this particular line of columns, this particular line of columns, also this particular line of columns and this particular line of columns should be deleted. So this one, clear selection. Those should be deleted. Now you can see what happens. The loads come here and the loads are resisted elsewhere. So these are the transfer plate works. And here also you can see all these column loads are coming here and they are distributed elsewhere. But now these columns are not having any foundation. So we save it. And then save B. And now you will see the (3D) at the corner. If you look at the corner, now here you can see we are having the transfer plate here, and then we are having the column here, but the piles are located elsewhere. So what we have to do is we have to actually locate the piles at the correct location. So how we can do that is we can actually go to the 3D view. And then what we do is we select all this and then say show selection only. And if I select here now, select this. Sorry, just one moment. Now we clear selection. So before doing this, we'll go to 3D now on this diagram and look at XY. So we look at the plan view. So this is also 3D view, this is a 3D view. But what is shown is only what you have selected. Just one moment. Sure. Oh, sorry. What we do is we'll go to 3D view. Look at this. Right. And then what we do is we select all that, say show selection only, and then we'll go to 3D view and look at XY. And now you see only that particular plane. And then what you do is we can actually select. So if I go to 3D here, just have a look. And when I select at this corner over here, so you can see that I can select the the 4 piles with the piles. I can select the pile cap with the 4 piles. So what I can do is now I can replicate this at minus 1.5 and minus 1.5 once, and I can delete the original object. Undo. Replicate once, and then these are overlapping and it's not okay with that. Okay. And then what you do is here again you have to move it and replicate minus 1.5 so we can replicate and on this side also we have to do that. Replicate by 1.5 and replicate this by minus 1. So there are few blanks to be filled. Then you get replicate by replicate, and also we have to do the same thing for these. So this way, you can ensure that the file caps, if you look at one of the corners, now you can clearly see that the column above comes here, column below connects the transfer plate and the file cap, and then the files start at these locations. So if you look at from side, display 3D, so view 3D, so view 3D, XZ, and here you can see the files are located clearly, properly. So the roads are coming from above, and then they are transferred through the transfer plate to here, and from there they are transferred onto the files. So this way you can create a transfer plate, but there are so many blanks to be filled that we have to do. But in general, you can actually create a transfer plate this way, and you can ensure that there's adequate continuity. And because we have done it sometimes, if I analyze this, it might analyze. And if I go to 3D view and show all building is there, and we can have a very brief look at whether it looks okay. And yeah, it looks okay. And except for, we have to view, it said 0, and there are few blanks to be filled. Similarly, so with that, it looks okay. So we can ask it to analyze. And the structure is analyzed. And then we can view 2D in that plane and ask it to display shells M22. So you can see the loads that are acting on the pi cap. And the reason is that, there are piles at these locations. And I'm looking at M22, which is in this direction. M22 is in this direction. So there's a pile here, there's a column here. And this column transverse is, so the M22 is this direction. So there are piles here, the columns here. So because of that, you will get a maximum bending moment here. And when you know the maximum bending moment, you can design the pile cap. You can design the pile cap. So that is something that we can see. And also we can see what's happening at the transfer plate by looking at 3.6. And then we can say display XY long diagram. And here again, you can see what happens at the location where this column is transferring the moments, and you can see M22 diagram maximum. And when you are looking at this, it's a good practice to see what happens when you look at the minimum as well. So when you look at the minimum value, they are lesser. So which means what we should be looking at is the maximum. So we look at the maximum. And here you can see the bending moments are fairly high, something like 3,489, or it can go up to 3,927. And the biggest problem that you get in this type of situation is the punchy shear and the shear around the load. And in addition to that, the way that we have arranged the transfer plate, you can see this particular column is at the edge. And that is also maybe a disadvantage. So it may be advantageous to actually extend the transfer plate a little more so that a bigger area will be available for checking when you check for punching shear and so on. So it may be a good idea to have little more space in the transfer plate if possible. If it's not possible, then you have to live with it. But if it is possible, then you can have little extra area so that the column will not be located at a corner. So you can see that doing this kind of analysis, you can actually get the bending moments, shear forces, and axial forces acting on columns, the piles, and also we can get the loads on the pile caps, transfer plates. In addition to that, we can get the natural period of vibration of the structure that can be used for calculation of wind-induced accelerations. So, and also, if you want to extend this, like go into this view. Here you can see we have only one transfer plate and one flow below it. But in general, you might have more than one flow below it. So one thing that we can do is I'll save this C. And then what I can do is select all that and then move by say 3.6 into 3. That means 3 more floors. But another thing you can see is, now the transfer plate is 2 meters thick and the flow to flow height we considered here is only 3.6 meters. So I can add 2 meters extra to this and then move all this by 12.8 meters. And then what I can do is you can select all these and replicate at 3.6 3 times. Don't delete the original object. And then what I can do is I can select this flow and then move it by 2 meters. And this way I can actually create the actual structure where I have 5.6 meter flow to flow height here to accommodate 2 meter thick transfer plate. And in addition to that, I'm having 3 floors of transfer plate as well. So you can actually go into 3D view and then do these modifications fairly fast. And then we can ask it to analyze as well. And I think you would have noticed that, the moment we introduced the transfer plate and made the structure wider, earlier the natural period of vibration reduced. But because now we have added more floors, it should increase. And earlier it was something like 0.43, then it came down to about 0.4. Now you can see it has gone up to about 0.422. So you can see now we have 3 floors, 1, 2, 3, 4. 4 floors of car parking and the office building and the pile foundation, everything modeled together. So any questions on this? The important thing is, I have deliberately ensured that these places, the connectivity is here. The elements are properly connected. And in addition to that, in the transport, I have divided it so that, you get a reasonable number of elements. And also it's possible for us to go a little further, and that is now this is a transport level, and if you want, you can actually improve the accuracy of your analysis. By dividing, save as D, edit areas, divide it further by 2 by 2. So you'll end up with a finer mesh here, and I can do the same thing at this level, and some of these file caps. I'll select 3 file caps. And then analyze. Display. So you might be able to get some better results because of the finer mesh. So any questions up to now? Done it? Is it okay?
Yes, sir.
Yeah. Gaushikan?
Yes, sir, it's fine.
Fine, right. So with that, we'll stop here for about 15 minutes. And after that, we'll discuss, box culverts. And those who are doing bridge engineering, have you learned the Euro code loads or the British code loads?
BS, sir. British.
BS, huh?
Yes, sir.
You
Yes,
are familiar with BS loads, is that right?
Yes, sir.
Okay, so I'll also use the BS code loads, but I will just highlight. It's only the loading, the loading is slightly different. So I'll use British loads for introducing, and I'll just highlight what's important in Euro loads. So shall I stop the lecture there on tall building modeling? So I have shown you almost everything that you can get, except earthquake analysis, because Dr. Sujeev is doing the earthquake analysis.